Hola guys, so as you can see here, there is this is the whiteboard actually. So I'm using the default method to introduce you with the topic, which I think not so difficult and not so easy either. It is the linear equation in three variable. We have three system of equations. Basically, this is linear equations. So we have three variables which are x, y, and z. We are going to solve for the value of x, y, and z. So first of all, I'm gonna introduce you with my own step-by-step technique in order to solve this problem. So what's the first step to solve this question? So first of all, okay, you need to this is actually the basic thing that you need to know. You need to simplify the equation if possible. Okay, let me write the if using the capital IF to emphasize that if possible. So if it is not possible, then don't do it. Okay, and then the second thing is you make variable as subject of formula. So actually, suppose you need to choose the variable which has a coefficient 1, because it is easier for you to make it as a subject. For example, this x, okay, the coefficient actually a 1, so you just shift everything to the right hand side and you will get x as the subject of formula. But instead, if you have like these two, in order to make x as a single or as a subject, you need to divide the whole equation at the right hand side by 2, because we need the x, not the 2x as a subject. And number 3, we do the substitution. Basically, in this video, I'm going to show you the method of substitution. Actually, you can do other methods like elimination and also the matrix method, but in this video, I'm focusing on the substitution method. So do substitution. So subs, okay, stands for substitution to the rest of equation. So equation eqn. Okay, that implies that into our problem right now. So let me erase that. So let's label the first line x minus 2y plus 3z equals to 5 as equation 1, and do with the rest of the equation. As I mentioned, the first step is we simplify. So let's have a look on the equation 1. So we have here x minus 2y plus 3z equals to 5. So I think this is the simplest form. And then equation 2, 2x minus y plus 4z equals to 1 is also simplest. And maybe we can do something from equation 3 for x minus 2y minus 8z equals to 0. So as you can see, this is the term here, 4, 2, and 8 can be divided by 2, or the factor of 2. So we just simply can simplify this expression, or not expression, equation, by dividing both sides by 2. So you must divide right hand side and left hand side by 2. And what we have, 2x. So this is y minus 4z. 0 divided by 2 is 0. So this is just equation 3 in the simplest form. So now I think I can erase this. So now we can work out this equation, because we have done the first step. Okay, let's make x as the subject of formula from equation 1. You can either choose from equation 2, y as the subject, or even from equation 3. Okay, you can either choose from equation 1, from 1, so I write that like that. So from 1, x equivalent to 5, okay, 5, and then we plus both sides by 2y, plus 2y, and then minus both sides by 3z, okay. So far so good. And then we label this as equation 4. Okay, from this equation we sub in into equation 2n, equation 2n 3. Okay, you cannot substitute inside the equation 1 because this equation 4 actually comes from equation 1. So let's substitute both 2 and 3. Then what we have from equation, I think I work on the equation 2 first. So equation 2, we have what? So we have 2 minus y plus 4z equals to 1. So this is basically x to x. So what I need to fill inside is from equation 1, which is the x. But x is nothing but just 5 plus 2y minus 3z, isn't it? Okay, and then we expand the bracket. We get what? Just expand And then you can further simplify, I think. 10 plus 4y minus 6z minus y plus 4z equals to 1. And then we simplify equation 2. So here you have 4y. Let's collect the 4y in the same position. So 4y minus y is 3y. Basically it's 3y. Okay, and then z, negative 6z plus 4z equals to negative 2z. Okay, 2z, you can see there. And then 10 I bring to the right hand side, so 1 minus 10 equals to 9. Negative 9. I hope you can see. And then we are done for equation 2. Actually not. Let's work on the equation 3. Okay, for equation 3, okay, you have that equation 3. So we have what? 2, okay, minus y minus 4z equals to 0. Okay, so suppose we this is x here, but x is nothing but just what? X is that 5 plus 2y minus 3z. So I just fill in with the x. X is just 5 plus 2y minus 3z, like that. And then we do the same thing, we expand the bracket. Okay, so this is the simplified form for equation 3. Okay, I am using the prime symbol to indicate it is being simplified. So this is 10. So we just expand the bracket. So 10 plus 4y minus 6z minus y minus 4z, like that. Okay, equivalent to 0. So we'll simplify this and that. 3y, okay, negative 6z, negative 4z is negative 10z. I bring 10 to the left hand side, to the right hand side, negative 10, because 0 minus 10 is negative 10. Okay, I will erase this side so that we have more space to write. So yeah, I have shift everything here so that we have more space to write. Okay, this is the equation 2 prime, which is the simplified form for equation 2 here. This is actually after we substitute this equation 1. Okay, x equals to 2y, x equals to 5 plus 2y minus 3z into the equation 2. Okay, this transform into this simplified form. And the same thing with equation 3. Okay, I substitute x value, which is the 5 plus 2y minus 3z into the equation 3. And then we get the simplified form, which is this, equation 3 prime. Okay, so we just left with the linear equation in 2 variable or 2 system. We can do substitution. You can also either prefer, if you prefer to do elimination, you can go for that. From equation 2, I think. From 2. Okay, I will make z as the subject of formula. So I will bring to the right hand side, becomes 2z, positive 2z. And I will bring this negative 9 into the left hand side. 3y plus 9, isn't it? And z as the subject of formula, we have what? 3y plus 9 over 2. Okay, so you can choose either from equation 2 or 3, you can choose either variable y or z as the subject of formula. And then I substitute in equation 3 prime. Okay, the simplified form. Okay, what we have, 3y minus 10z. Z is just what? 3y plus 9 over 2. 3y plus 9 over 2 equivalent to negative 10. So we can solve this because this is the linear equation in one variable. So this is basically, okay, you can cancel them. Okay, divide by 2, this is 5. So expand the bracket, so you get 15y plus 45 equals to negative 10. Okay, so 3y minus 15y minus 45 equals to negative 10. So 3y minus 15y is basically negative 12y equivalent to negative 10. This you bring to the right hand side, so it becomes positive 45 minus 10, which is 35. Okay, so we get y equals to 35 over 12, and I think this is the simplest form. the last step is to check whether this can be simplified into a simplest fraction or not. I think this is the simplest one. So we get y equals to, I missed the negative sign, negative. You cannot put bottom of the fraction, you need to put the middle of the fraction. So the value of y is basically negative 35 over 12. After you get the value of y, you can substitute for the value of z or z. So we know from equation 2 prime there, z equals to 3y plus 9 over 2. So we substitute z equals to 3y, y is just what? Negative 35 over 12 plus 9 over 2. You just press the calculator, or if you prefer, you can use your mental arithmetic to work this on. So I think this is 1 over 8. So z is basically 1 over 8, or 0.125. So we need to find for the value of x. From equation 1, we know previously x equals to 5 plus 2y plus minus 3z. So x equivalent to 5 plus y is nothing but just negative 35 over 12. 12 minus 3, z is 1 over 8. Okay, so we just calculate the value. I think this is not the nice evaluation, negative 1.208. So that's for the method of substitution. I hope you guys can understand how to do the question. I think you guys already learned about this linear equation in KSSM syllabus, isn't it? So I think it's not a messy task to do. I think it just need more practice to do this kind of question. So that's all for me, and thank you.